This unit that we're going to study now is all about logic and how we make decisions based on information that we've been given. Everything is going to come down to reasoning, and all of our decisions have to have sound reasoning. And then we'll also have to decide, based on what we're given, what information is true and what information is false. To start, I want you guys to go ahead and take a look at the 4 lists up here at the top. Each have a pattern. Come up with the next entry or the next item in each list, following the pattern. Go ahead and press pause. You only need to write 1 entry for each of the 4 in the next entry in the pattern. When you're done, unpause to check your work. So in part A, the next item would be July. In part B, the number would be 35. In part C, 25. And in part D, we'd fill in the little triangle on the left of our square. The idea here is that each one of these represents a different pattern. Part A, we skipped every other month. So we did January, skipped February, put March, skipped April, put May, and so on. In part B, it's multiples of 7. 7, 14, 21, 28, 35 would be next. There's 2 different ways to see the pattern in part C. Some people may have seen that we're adding 3 to the first one, then adding 5, then adding 7, then adding 9. We get 25. That pattern works. The other possibility here is that it's our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And then we see that the pattern in the last one, we shaded in the bottom, the right, the top, the left, we assume would be next. All 4 of those are examples of inductive reasoning. It's the process of making an educated guess. It's pattern recognition. You see a pattern and you apply it moving forward. This educated guess we also call a conjecture. The reason it's called an educated guess is because it's simply that. We've seen a pattern, we assume it will continue, and so we can figure out the next item in that pattern. But it is just a guess, so we have to know that our educated guess, our conjecture, is not always true. We will have to find ways to prove that the next step in a pattern might not be true, and in that case, it'll be a false conjecture, and we will have to do one additional piece of information. Moving on to goal 1 here, it says to determine if a conjecture is true or false based on given information. So, in order for that conjecture to be true, it must be true all of the time. If it's false, it only needs to be false once. It can be true 999 times, and then on that 1000th time, if it's false, the whole thing would be considered false. That one item that can prove any conjecture false is called a counterexample. And let's make sure I spell it correct. C-O-U-N-T-E-R. So, you only need one counterexample. However, that counterexample can't just be anything. It has to be something that makes your given information true. That is really important. We can't just go off and make up some crazy random example. It has to be an example where any given information is already true. It's only going to make your conjecture false. Let's look at a few examples here. In number 1, we're given that points A, B, and C lie on the same segment. We're not given anything about order. We're not given anything about any more information. I just know that I have a segment, and on it are points A, B, and C. The conjecture is that they are collinear. So we have to assume that this is true. I can't come up with any example that makes that false. but then see if we can figure out, is there any possible way that this conjecture is false? In this case, there's nothing. So we would state that this is a true conjecture and a true statement. Some of you may be saying, but wait, what if I had this? A and B and C. Those are not collinear. You're right. It makes that as an example where my conjecture is false. But my given is also false there. And that is why this can't be a counterexample. These do not all lie on the same segment. So this makes my conjecture, or my given, false, so I can't use it. I'm going to erase it because it's something that we can't use. If it makes your given false, it can't be used as a counterexample. In number 2, same given. So I'm given that these all lie on the same segment, so we can look at the example up here. But now it says that B is between A and C. If I look at what I wrote up in number 1, that looks like that's true. But can we come up with an example where they are all still on the same segment and B is not between A and C? And the answer to that is yeah, we can. This is false. Now, if I ever state that a conjecture is false, I must provide a counterexample. So, my counterexample here would be this, A, B, C. Points A, B, and C lie on the same segment. That's still true. They're all on the same segment. This given doesn't say anything about order. But my conjecture, B is between A and C, is false. B is not between A and C, so the conjecture is false. Why don't you guys go ahead and try number 3 on your own right now. You can stop after 3. 4 is going to be a little trickier. If you want to go on, but I will go through and walk through number 4. Hit pause and try number 3. Decide if it's true or false. If it's false, write a counterexample. When you're done, unpause to check your work. So for number 3, it is a false conjecture. I have a counterexample here that does show A is between C and R, but segment CA is not congruent to segment AR because segment CA is only 1, segment AR is 4. They're not equal. You don't have to have a counterexample that matches exactly with mine, but it does need to, first of all, have A between C and R on a segment, and somehow mark the fact that A is not the midpoint. Whether you use segment lengths like this, or if you put little tick marks in here and say that's 1 and that's 2, you're showing that it's not congruent. Somehow come up with a conjecture that proves this is false. Now, number 4, this one's a little trickier because we haven't talked much about angles other than vertical angles. And when we did talk about vertical angles, we told you they are congruent. So it's easy to say, well, A and B are congruent, then A and B must be vertical angles. And similar to number 3, it's true that if they are vertical angles, then they are congruent. However, I can come up with an example. Here's my example where that's true. But what if I did this? And I said, here's angle A. It's 50 degrees. And then I came over here and I said, here's angle B. It's also 50 degrees. They're definitely congruent, so that makes my given statement true, but they're not vertical angles because they are not formed by intersecting lines. So this would be my one counterexample needed to prove the conjecture false. On our next video, we're going to start talking about conditional statements, and we'll talk about how the fact that conditional statements are just another way of writing a given statement with a conjecture.